Hello students, subscribers, and viewers. Here is problem 11.5a, previously solved in 9.5a by the three-moment equations. In there, I solved it in more details like the support reactions. Here, we're only going to generate the internal moments at C and D and verify that the answers to problem 9.5a as well as in 10.5a solved by the slope deflection equations are the same. So first, we have support movements, downward movements. E is 200 gigapascals, I is 500 times 10 to the 6 mm to the fourth. So therefore, the value of EI is 100,000 kilonewton meter square. So I hope you know that from the previous uh, exercises, problems, videos, and experiences. So fixed moment BC is due to the load. The couple is counterclockwise, and in the formula from 6 formula by slope deflection equations, it is moment. In this case, it is negative in the formula because in the derivation, clockwise is positive for slope deflection equation. Times B, and B is 2 meters here. And divided by L square times quantity 2L minus 3 times B. So the value is negative 38.4 kilonewton meter due to the moment, fixed moment due to this couple load. Then for support settlements or side sway moment, negative 6 EI. And EI is if the moment of inertia is I, 100,000, but if the moment of inertia is 1.2 of I, it is 120,000 kilonewton meter square also. Then delta is treated negative because the rotation of chord BC is counterclockwise. The difference delta is 12 minus 8 for mm. So that's why for mm in meter, negative 0.004 meter. So is treated negative. Divided by L square, negative 6EI delta over L square, that's the side sway moment or moment due to support movements or settlements. And the value is 115.2 plus negative 38.4, so the net value is positive 76.8 kilonewton meter. So put it in this tabulation here. By the way, the stiffness of member BC, this is my technique. Although this is an interior span, I'll imagine that B is the end support. Then I just transmit the effect of this overhang here, 15 kilonewtons. So imagine there is 15 kilonewtons here. And the moment of 15 kilonewtons is 15 times 2, so 30 kilonewton meters. So there is a couple of 30 kilonewton meter. But the moment in BC is negative, negative 15 times 2. So it is negative 30 kilonewton meter for BC. But for BA, it is positive 15 times 2. So 30 kilonewton meter there. And the side sway moment BC, fixed moment BC is 76.8 kilonewtons. So therefore, because I imagine this is my technique, you may not follow this, but I find this easy and shorter when you treat the overhang as you cut it and you just transmit 15 kilonewton downward, and this is the last. So that this is an end span with far end pin so that its stiffness is modified by multiplying 3/4. So by the principle. So 3/4, that's why you have to read, for those first timers, you have to read the lecture video in slope deflection equations that I uploaded also in YouTube. So 3/4 of I over L, and I is 1.2. EI is in general treated 1. So 1.2 divided by L5. So it is 9 over 50. This is an interior span CD, so it is just I over 6, and I is just I, so 1 over 6, 1 over L. Then again, DE, we have an overhang, and I treat again EF, E as the last support, ruler support, and I just transmit the equivalent loading in the overhang here, which is 24 times 1. So imagine there is 24 kilonewton downward, which will not, uh, which has no effect in the bending moment because it is acting over the support. Only the moment, which is 24 times 1 times uh, zero point 0.5 or 12 kilonewton meter will be transmitted also. So 24 kilonewton downwards and a couple load of 12 kilonewton meter. The moment in EF is negative 12 kilonewton meter. So that the moment in ED should be equal numerically to 12. So it is positive 12. Later we can find that. So that's it. That's why the stiffness is modified by multiplying 3/4. So 3/4 of, since I is 1.5 I, so 1.5 divided by L for 9 over 32. So that is distribution factor, therefore, because this is the end support B, there's only one member, is -1 by experience also. At E also, there's only one member, only DE. So imagine, remember that I cut that, the overhang is removed and transmit the loading and equivalent couple. So -1. Let's continue. Fixed moment CB is due to the load, -120 A, and A this time is 3 over L squared, quantity 2L minus 3A. And plus the side sway moment, which is the same, 115.2, then you will get 100.8 kilonewton meter. So CD, the fixed moment is due to the load, negative W 24 L square 6 square over 30. This is this, negative 28.8. Then side sway moment, negative 6 EI, since I is I, so 100,000 back. Then delta is treated positive again because the rotation of chord CD is clockwise. And delta is 14 minus 8, 6 mm. So positive 0.06 meter over L square 6 square. And it is negative 100, so negative 28.8 minus 100, negative 128.8. Then DC, due to the load, it's positive here at the right, WL square over 20, 24 6 square over 20, then side sway moment negative 100, so negative 56.8. So we have negative 128.8 here, negative 56.8 on this side. Then fixed moment DE, due to the load, negative WL square over 12, negative 24 4 square over 12, which is negative 32 due to side sway moment, negative 6 EI 150, which is 6 times 150,000. Delta is again treated negative because rotation of chord DE is counterclockwise, and delta is 14 mm minus 6. So 8 mm, negative 0.008 divided by L square 4 square. So it is positive 450 minus 32, so 418 kilonewton meter. Then finally ED, because of symmetry, the load, the fixed moment due to the load is positive of this. So positive 32, then side sway moment remains 450, so 482 kilonewton meter. And of course, moment EF is negative 24 times 1 meter times 0.5, so negative 12. The next step is to distribute this unbalanced moment. Quantity 30 plus 76.8 times negative 1 is negative 106.8. So we log it finally because we know that the final moment BA is 30 and the final moment BC is negative 30. 76.8 minus 106.8, that's negative 30. So that is already balanced. Same is true at E. So quantity 482 minus 12 is 470 times negative 1. That's why we have negative 470 here. And we lock it finally because the final moment there is positive 12 in ED. And the moment in EF is negative 12. Later, this is 12 and negative 12. This is 30 and this is negative 30. Then for this joint C here, the unbalanced moment 100.8 minus 128.8, and this is the distribution factor 9 over 50 divided by quantity 9 over 50 plus 1 over 6. It's make it negative 27 over 52. So the other value negative 25 over 52, because remember the sum should be 1. In DC, it is 1/6 divided by 1/6 plus 9 over 32. So negative 16 over 43. And on the right side, negative 27 over 43. Oh. So 100.8 minus 128.8, close in your calculator, times negative 27 over 52, 14.538. Replace 27 by 25, 13.462 in your calculator. So here, quantity negative 56.8 plus 418, close, times negative 16 over 43, negative 134.4. Replace 16 by 27, negative 226.8. Then, carry over. So half of negative 106.8, negative 53.4. Then we don't carry over half of 14.538 here anymore because this is the guide. We have to lock it finally. So meaning to say no more moments should be distributed and carried over on this column here as well as on this column here. So then half of negative 134.4 is negative 57.2. Half of 13.462, 6.731. Half of negative 470, negative 235. So half of negative 226.8 supposedly here, but since this is finally locked, so meaning to say we don't carry over half of negative 226.8. So that's it. These are the new moments at C and D. So we have to distribute again. So quantity negative 53.4 minus 57.2 times negative 27 over 52. You'll have 62.619. Replace 27 by 25, 57.981 there. Then here, quantity 6.731 minus 235 times negative 16 over 43. That's the value. Replace 16 by 27. That's the value. Then carry over because this is a repetitive process cycle until such time that the distributed moment would be very, very small or less than our guide, less than absolute value of 0.1. So it is none here, none because there's no moment, as I said there. Then half of 84.937, that's 42.468. Half of 57.951, that's 28.990. Half of nothing here, so that's why it's none here. Then 42.468 times negative 27 over 52, that's the value, times negative 25 over 5 square over 52, that's the value. 28.990 times negative 16 over 43, that's the value. Replace 16 by 27, that's the value. Then carry over, none here, half of negative 10.787, half of negative 20.417, and so on and so forth until you end up with distribute. And if the moments, disputed moments, would be very, very small, as I said, it's less than absolute value of 0.1, then you may stop. If you want the answer to be the same as in three-moment equations and slope deflection equations, then you may go on until such time that the value distributed is very small, 0.001, for example, 0.002. That's the time you end if you want. But I just end here, and these are the final moments. Final moments, so we have 30 here. Then here it's negative 30. Here it's positive 104.402 as compared to 104.406, the accurate value. Remember, this is just an approximate method. Then negative 104.402, they are numerically equal, so that means the tabulation is correct. Then here, negative 87.175, here 87.175 as compared to 87.187 in both methods, three-moment equation and slope deflection equation. So that's it, because the video lengthens, and I know that you don't want long videos.